Algorithms are difficult. I realized this when I was in my second semester and I wanted to learn algorithms. So I opened up Google, typed in data structures and algorithms, opened the first link and then closed it within a minute because I didn't understand anything. And surprise, surprise, almost every tech company interviews you on data structures and algorithms. And I got a total of 0 internships. Why was I like that? So once I started solving questions, I solved over 950 questions before I was able to get into Google. And I know you don't have the time and energy, so I have made a list of questions, over 100 of them. So these questions are top secret. I could get in trouble with the big tech or the curve. I should stop reading conspiracy theories. Moving to algorithms. First of all, we have searching. There's two types of searching, that is linear search and binary search. In an unsorted array, we use linear search, and in a sorted array, we try to go with binary search. Linear search checks every element for the required element, and binary search chooses the midpoint and then slices the array in half and then goes to the right side or the left side. Linear search takes O of n time, while binary search goes till O of log n. So binary search is a lot faster. And there's a few questions that use binary search in a lot of intuitive ways that I have added in the sheet that you can download by clicking the first link in the description. Next up, we have sorting. So there's 6 types of sorts that you need to know: bubble sort, selection sort, insertion sort, merge sort, quick sort, and heap sort. The first 3 are pretty simple, but they have an average time complexity of O of n square, while the rest of the 3 have an average time complexity of n log n. The worst case for quick sort is still O of n square, but it is a little complicated in how you choose the pivot element, so you should try to implement all 6 of them from scratch, especially the last 3. And merge sort and quick sort have other use cases as well, like count inversions that uses merge sort. Next up, we have arrays. You should know how to define an array, store it, iterate it, how it's stored in the memory. If you don't know all these things, don't worry, you can check out this video in the I button where I go over almost every data structure and how it's stored in the memory, the use cases, and everything around it. Then you should know how to reverse an array, how to rotate an array. Before picking up the questions, make sure you know the difference between subarray and subsequence. Subarray is like part of an array, but you cannot skip elements in the middle. Whereas in subsequence, you can skip some elements in the middle, but you cannot mess with the order. Arrays are a really vast topic, but some important algorithms are Gadane's algorithm, the 2-pointer approach for, let's say, 2-sum and 3-sum, the subarray sum to k, sliding window, which was really difficult for me for some reason when I was trying to study it. Moving on to 2D arrays or matrices. You should know how to take inputs, outputs, print it. You should know how to print it in a spiral, because for some reason I've been asked that in interviews. And then you should know how to take a transpose of a matrix, and then there's a little trick that you can use to rotate the matrix. It's not that difficult, but it is really hard to come up with if you haven't done it before. So 2D arrays are used a lot in backtracking and graphs and a lot of DP questions. Moving on to strings. Again, similar to array, you should know how to take an input, output, print them, how they are stored in the memory. Then you should know what a palindrome is, and you should be able to check if a string given to you is a palindrome or not. If you can do that, the next step would be checking the longest palindrome that is present in your string. Similar to arrays, this has a substring and a subsequence, and they have the exact same definition. In substring, you cannot remove characters from the middle, whereas in a subsequence, you can pick up random characters, but the order should be maintained. So there's a bunch of interesting questions that were asked repetitively in a lot of interviews, like the longest substring with all unique characters or the shortest substring containing all the characters of another string. Both of them are pretty similar questions, so it will be fun to solve one if you can solve the other. And there's a bunch of different questions that I've tried to include in the list. Next up, talking about recursion and backtracking. Hands down, this is my favorite part of data structures and algorithms because it is so easy to come up with solutions to problems that seem really hard. Backtracking is just an extension for recursion where you generate a solution and you try to check if that solution is valid. If it isn't valid, then you move a step back, generate another solution. If it is valid, then that's like a base case. So you print it or store it and then you move back. One really simple example is a Sudoku. So whenever we try to implement a Sudoku solver, we try to input numbers that seem correct and try to see if we can solve the Sudoku till the end. If we cannot do it, we move back, we try another number, and we keep on doing this until the Sudoku is solved. And there's a bunch of interesting questions on both of these. You will need a solid grasp of recursion and backtracking when you are solving dynamic programming questions. So I have added a bunch of questions for recursion and backtracking in the list. It's an overkill and you don't have to solve these many questions, but it will really help you. Moving to stacks and queues. So stacks and queues are based on arrays. If you don't know about it, check that video. And I have not seen a lot of standalone questions for stacks and queues, but they are really important in a lot of other algorithms like BFS and DFS. But what you should know is how to implement them from scratch. One really interesting question is implementing k stacks in a single array. Next up, we have linked lists. So you should know how to iterate it, how to take an input, how to display them, how they are stored in the memory. You should know how to reverse a linked list and reverse it in pairs of k elements elements at once. And you should be familiar with the fast and slow pointer approach that is used to find the middle of a linked list, or use it to find a loop in a linked list and then remove it. Other than that, you should try to implement merge sort and quick sort in place in a linked list. And then there's this question where you need to copy a linked list with a random pointer that I've been asked in an interview and I didn't know how to do it. Similarly, for doubly linked list, try to do all the same. And one important question that comes to my mind is LRU cache. Moving on to non-linear data structures, trees, specifically binary trees. So you should know all the ways to traverse a binary tree, that is pre-order, in-order, post-order, level order, and you should be able to write them recursively as well as iteratively. You should know how to find the depth of a tree, how to find the diameter of a tree, how to find the left view, the top view, the bottom view, and the right view of the tree. You should be able to mirror a tree and copy a tree. There's a bunch of different questions on trees that you can go in. One really important topic that you should do is lowest common ancestor. There's a bunch of algorithms that are based on BFS and DFS in a tree. They lean towards graphs a little, so try to pick those type of questions when you are doing graphs. Similarly, for binary search tree, you should know how to implement it, how to save it, how to iterate it in all the ways, and you should be able to check if a given binary tree is a BST or not. You can try to convert a sorted array in a BST, and obviously try to find the lowest common ancestor for 2 nodes in a binary search tree as well. Moving on to tries, there's not a lot here. Just try to implement it from scratch and try to add words and search for words. That's pretty much it. Talking about heap, heap is a really important data structure, but you should be able to implement it using an array. Once you have a heap, a min heap or a max heap, try to insert an element, remove an element, and implement heap sort from scratch. The main type of questions in which heaps are really useful are when you have to keep k elements together sorted. It could be a min heap or a max heap, so you can keep the k largest or the k smallest elements. Next up, we have dynamic programming. Dynamic programming, in essence, is really simple. You basically have a problem that can be broken down into smaller problems, and you need the solution of smaller problems to create the solution of the larger problem. That's pretty much it. It's written as overlapping subproblems and optimal substructure. So there's basically 2 ways to do it. Either you can write a recursive solution and memoize it. So whenever we generate a solution, we store it in an array, and before generating the solution, we check the array if we already have the solution. That's called a top-down approach, or recursion with memoization. In bottom-up, you create a table from 0 and you start filling it. That's pretty much all dynamic programming is. So there's a bunch of questions in dynamic programming, and I would suggest that you spend a lot of your time in this section. Cool. Moving to graphs. You should know how to implement a graph from scratch, how it is stored in the memory, how to create the adjacency matrix and the adjacency list, what are the differences, what are the use cases. You should know how to create weighted and directed graphs. Talking about algorithms, you should know how to implement breadth first search and depth first search, and you can try to implement them on a tree or a 2D matrix. Other than that, you should try to implement Dijkstra's algorithm, which I've been asked in so many interviews that I can't even count, including the interview that I gave to Google. Similarly, learn about topological sorting, minimum spanning tree, Prim's algorithm, Kruskal's algorithm. You'll also learn about union find algorithm. Some other algorithms that I haven't been asked but are good to know are Floyd-Warshall and Bellman-Ford. So Google all these terms, get to know what they mean, and try to implement them. So that pretty much covers the list. This is not an exhaustive list. There's a lot of questions outside the list that are amazing, but this list covers a lot of questions that are asked a lot. It's a good starting point, and if you have time and the energy, you should go ahead and try to solve a lot more questions than this. But this is a pretty good starting point. But in order to make the most of this list, you should have a pretty good understanding of data structures. In fact, data structures are pretty much the most important part of an interview. So you should check out this video if you want a deeper understanding of all the required data structures and how they are stored in the memory and how they work. See you.